Okay, and yeah, as we said already in the beginning, we are using here an AC or audio voltmeter or millivoltmeter, whatever. So I'm using this unit still, as it is for me a very nice meter for doing receiver alignments, okay? But you can use it for this signal-to-noise testings as well, and that is what you can see here. This meter can be used from 2 Hz up to 12 megahertz. So when this meter was built a couple of years, or maybe better decades away, this 12 megahertz was very important, as it was possible to use this meter for IF frequencies, so normally for ultra short wave radios, where we had very often the IF sitting on 10.7 megahertz. So that means that this meter here was really able to test the 10.7 megahertz IF. Okay, so that was a really interesting unit at its time, but still, as it has a really nice big scale here, it is really nice to use it for alignments, because it is much easier to follow here an analog needle than trying to follow a digital display. So that is not very convenient, and even when you have your IF coils which you are aligning, so you really need to see the reaction on the meter, so you need really a fast response, and so you really want to see the trend, and therefore meters like this are excellent. Okay, but now back here to our signal to noise measurement. So first of all, I connect again here this meter to the radio audio output. So remember, that is in parallel to our dummy resistor, and when I switch here over to speaker, you may hear, I don't know, the noise, and I'm testing now here the noise. Maybe I have to go to 100 millivolt. So our upper scale is the interesting one, and you see that the meter is bouncing a little bit back and forth. I mean, we are testing here noise, right? So maybe it is 40 millivolt. So our noise level is 40 millivolt. So simply assume that it really is 40 millivolt. You see it here bouncing a little bit back and forth. So let's assume it is 40 millivolts. Okay. Now we switch in our generator, and I've set the generator to minus 107 dBm, because that is the level what our specs are telling is, or should push for 10 dB signal to noise. So let me switch it in. Here we have our minus 107 dBm, and I have to go to the 300 millivolt scale, which is now this here, and yeah, it is again, you may hear it, it is still in the noise. Okay, so that is the meter which is freaking out here a little bit, but yeah. So it is, let me say it is 200 and, let me switch it off. Let me say it is 280 millivolt. Okay, so now we have both. We have the, let me switch out here the speaker. So now we have both. We have our noise level with 40 millivolt, okay, and we have our signal level, which is 280 millivolt. And as you have seen it in the specs, the ratio is always given in dB. So that means we have to work out what the dB is now on this both noise and signal level. So that is what we want to know. Yeah, again, let's have a look here back on our specs, and once again, so we are in AM mode, and greater than 1.5 megahertz, so we are here on 14.1 megahertz. We should see with 1 microvolt, or with which is similar, minus 107 dBm, we should see minimum 10 dB, right? And yeah, now we need really to convert our both figures. We have our 280 millivolt for signal and our 40 millivolts for noise. We need to convert it into dB, okay? And therefore we have here the formula. Let me go here that you can see it. So the formula is 20 times logarithm voltage signal to voltage.
あ、古い。はい。レシートはどうも。はい。あ、どうもどうも。